All right, so we're on section 3.2. We're going to talk about parallel lines again. We talked about that yesterday. We named them, right? But now we're going to talk about the relationship between as far as numerically. And we're going to use this quite a bit all throughout the book. So, I mean, not like every single lesson, every single chapter, but from time to time this will show up and you're going to have to remember a lot of this stuff. So, there we go. There's our picture. Now these just aren't any old lines this time, all right? This is a little bit different than we talked about yesterday. Yesterday I just drew just two lines and a transversal. This is not just any two lines. Guess what's true about these two lines? They're parallel. Now, could I tell they're parallel right away? No. Unless I do what? Yeah, draw these little arrows. Now, just looking at the picture, now I can say that they're parallel to each other. So what we're going to talk about today only works if the lines are parallel to each other. Does it make sense? So let's number them just like we did yesterday. My 3 is so weird. There it goes. 4, 5, 6, 7, and 8. All right? So it's the same kind of numbering as I did yesterday, but now we're not just going to talk about the names of them. We're going to talk about the relationship as far as if they're equal to each other, if they add up to something, or whatever. All right, so that's what we're going to talk about right now. So first thing we're going to talk about are the corresponding angles. Remember we talked about that yesterday? All right, so I'll tell you what, let's do this in black. All right, so let's write down corresponding angles. I'm going to shorthand it, and I'm not just going to put CA for corresponding angles. I'll put CORR. That's about as short as we want to get. All right, corresponding angles. Now let's take a look. I said angle 1. If I ask you what is a corresponding angle with angle 1, which one would you tell me?
5.
Angle 5, right. So 1 and 5 are corresponding to each other. Now just take a look at it. Look at angle 1. Describe angle 1 for me somehow.
Obtuse.
It's obtuse. You can just say it. You don't have to raise your hand. So look at angle 5. Again, it's obtuse as well. Just kind of look at it. Just like in your head, what do you think might be true about this angle 1 and this angle 5? Yeah, it looks like about they're equal, doesn't it? Okay, because look, if they're parallel lines and this one slants a certain way, the slant doesn't change when it gets to this line, does it? It's the same exact slant, so it's going to create the same exact angle. So angle 1 and angle 5 are actually equal to each other. We have a thing called a postulate. Let's write that down. Postulate. A postulate is basically like a rule, R-U-L-E, a rule or a law or something like that that tells you something is true. This one right here, this first one, is called a postulate. Now, we skipped chapter 2. Chapter 2 had some things in there that I'm going to have to bring up every once in a while. All right? Talking about things, proving things. Okay, we'll talk more as we go on about proving things right now. But a postulate does not have to be proven. A postulate is just accepted as fact. All right? I don't have to prove it. I don't have to sit down there and say, well, show me why angle 1 and 5 are equal to each other. You really can't. All you can say is that they are equal to each other. We okay with that? So this first thing is a postulate. And if you look in the book, they actually number a lot of these postulates. They'll put them in boxes and things like that. They happen to number this particular postulate, postulate 3-1. Where do you think they get those numbers from? 3. Why would they call it postulate 3, first of all? It's chapter 3, exactly. Why 1? It's the first postulate, exactly. It's the first postulate we're doing in chapter 3, so they call it postulate 3-1. I do not want you to memorize the numbers of these postulates, okay, or these other things that are called theorems that we're going to do a little bit later too. Don't memorize the numbers because this particular book put this topic in chapter 3. Do you think that every single math book across the world is going to put this topic in chapter 3? No. So postulate 3-1 is just numbered that way because it's the third chapter, it's the first postulate. Okay, so we don't memorize them by the numbers. I'm telling you though, there are teachers out there, I've heard that there are teachers out there, geometry teachers, that have their students memorize them by the numbers and they have them memorize word for word what the postulate is. All right, nothing against them, but I just don't think that that's a very practical thing to do. All right, so I'm not going to have you memorize all these postulates word for word. I'll never give you a quiz or a test where I'll say, okay, list the first 5 postulates and number them and write them out for me. I won't do that. There are some geometry teachers that do that, okay, and I don't. But I still want you to learn what they are. Leah, did your teacher do that in the past? Oh, because you look like you're smiling like that's happened to you before. Okay. So, corresponding angles. Now, what did we say about 1 and 5? They're corresponding, and it looks like they're equal to each other, aren't they? All right, and they absolutely are. So here's the first postulate. First postulate says this. I'm going to shorthand it real big time, okay? Look what we have, though. The postulate says this. If, it doesn't say we, but I don't know, what do they say? If two parallel lines, okay? If two parallel lines are cut by a transversal. Do we have that situation here? Yeah, we got two parallel lines, and we have a transversal. Then the corresponding angles are congruent or equal. I'm fine if you use equal or congruent, it doesn't matter. So if you have two parallel lines, which we do, cut by transversal, which we do, then every time you see corresponding angles, then they're going to be congruent to each other. So I shorthand it and just say corresponding angles are congruent. Okay, we'll talk about that in a second. Just hang on. All right, so that's our first postulate. A postulate is accepted without proof. All right, we just believe it because they told us. All right, so corresponding angles are congruent. That's supposed to be an equal sign with a little squiggle on top. That's congruent. Yes, Matt.
Since 1 and 5 are congruent,
yep.
Does that mean 5 and 4 are congruent also?
Yes, it does. Yep, and we'll talk about that in a second, okay? So watch. 1 and 5 are equal to each other. Let's list, first of all the corresponding angles and which one are congruent. Yesterday we listed them, but we didn't say anything about them being equal, did we? We just said these are our corresponding angles. But today we're gonna list them out. So let's list them in red. All right. So let's talk about angle 1. Angle 1 would equal what? Because they're corresponding angles. Angle 5. Let's keep going. Angle 2. 6, and then what else? 3, 7, and then 4, 8. All right, easy enough. Look what I did. They're all equal to each other. Yesterday, I just put commas between them. Remember that? I just said these are our corresponding angles. I didn't say anything yesterday about them being equal or not, but they are equal to each other, so 1 and 5. Matt brought up a good point. Watch. If 1 equals 5, look what else equals. 5 equals what else? 8. Okay, so if 1 equals 5 and 5 equals 8, guess what?
1 equals 4.
1 equals 8, doesn't it? And 1 equals what? What else? 4 as well, doesn't it? Okay? Do you agree? So 1, 4, 5, and 8 are all equal to each other. Make sense? That's pretty easy. So what do you think's true about 2, 3, 6, and 7? They're all equal to each other as well. All right? So look, all the obtuse angles are all exactly the same. And guess what? All the acute angles are also all the same. All right? Make sense? All right, so just from knowing this, just from knowing that the corresponding angles are equal, we can say all these other angles are equal as well. But let's do this. Let's look at some relationships, though. Look at 4 and 5. What's true about 4 and 5 as far as their name? What's the name of the relationship between 4 and 5? Right, alternate, and I'll shorthand it like this. Alternate interior angles. What do you think is true about alternate interior angles then? 4 and 5. They're congruent. That's right. So this is not a postulate, though. This is a theorem. Theorem. No, it means it's always true, but it can be proven. All right. So postulates don't get proven. Okay, they're just accepted facts. Theorems are still facts. They're still true, but you can prove them. All right. For instance, that's kind of what we did right here, isn't it? Look, I said 1 and 5 are equal. Give me a reason. Give me a reason. I'm going to put why. Give me a reason that 1 and 5 are equal to each other. Because they are what? What's my postulate say? Because they're, no, 1 and 5. Because corresponding angles are what? Are congruent. So my reason would be this, that corresponding angles are congruent. I'll really shorthand it. Don't even put the R in there. Okay, so corresponding angles are congruent. That's the why. I'm leading you up to something you don't even know it. All right, I'm leading you up to things called proofs, and we need to back up our statements with a reason. Okay, and our reason is that corresponding angles are congruent. So why do you think 2 and 6 are equal to each other?
Because they're both acute angles.
Nah, come on, look at it. That's right, same exact reason. Okay, look, 1 and 5 are congruent because corresponding angles are congruent, right? I have a postulate that says that. Agreed? Now, technically, that's not the whole thing. There's a little if part in front of it. What's the if part? If If two parallel lines cut by a transversal, then the corresponding angles are congruent. I kind of leave that out, all right, but that's okay. We just kind of know that, don't we? All right, so I just say the corresponding angles are congruent. What about 2 and 6? Look at it. They're corresponding angles, right? So what must be true about them? They're congruent. Why? Because there's a postulate that says what? Corresponding angles are congruent. Why is 3 and 7 equal to each other? Because corresponding angle. Talk to me. Come on. Corresponding angles are congruent. Why are 4 and 8 equal to each other? Because corresponding angles are congruent. Exactly. You get it? All right. That's what we need to understand. That if I ask you why, that you list what the postulate says. Don't say because of postulate 3-1. I don't care about the numbers. I'll never refer to these postulates according to their numbers. You follow me on that? I want to know what it says. And it doesn't have to be word for word, but you should at least put corresponding angles are congruent. That's enough right here. We got a nice little shortcut, right? That's not too much to write, is it? All right, so corresponding angles are congruent. All right, let's talk about this. 1 equals 5. Why? Okay, corresponding angles are congruent. Now watch. 5 equals 8. Why does 5... let's do this. Let's do this. 1 equals 4. So watch. Angle 1 equals angle 5. Why? Because the corresponding angles are congruent. All right? What else does 1 equal?
4.
Angle 4, doesn't it? Give me a reason for that. Why does 1 equal 4? Because vertical angles are what? Congruent. So I'm going to shorthand that. Watch. Vertical angles are congruent. You can just say equals if you want, but I'm going to say congruent. Okay? So watch. If 1 equals 5 and 1 equals 4, look, they both equal 1. So guess what? Then they both what? Equal each other. Do you see that? So if they both equal 1, they both equal the same thing. So angle 4 is equal to angle 5. So 4 and 5 are equal to each other. And guess what 4 and 5 are? They're alternate interior angles. What we did right there, we used a postulate to prove this theorem. We basically just proved alternate interior angles are congruent in a really sketchy, shortcut kind of way. All right, but that's all I wanted you to see. So all I had to know is that 1 and 5 are equal then, and I already know that 1 and 4 are equal because they're vertical angles, something we learned in chapter 1. So therefore 4 and 5 must be equal to each other as well. You got it? So that means, what do you think my theorem says? That alternate interior angles are what? Are congruent. That's right. So anytime you see alternate interior angles, I don't have to go through that whole thing with 3 and 6. What can I just say about them? Yeah. So let's list the alternate interior angles. Angle 4 equals angle what?
1.
Well, the alternate interior angles. 4 and 1 are alternate interior angles. What are my other alternate interior angles?
3.
Angle 3 and angle 6. Okay, they're equal to each other as well. Rachel?
Does that mean alternate exterior?
They absolutely are. Good call. So watch. Look at this. 1 equals 4, right? 4 equals... Well, let's go through the reasons. Why does 1 equal 4? Because... No, don't say all that stuff. Say this. Vertical angles are congruent. That's all you got to say. Try one more time. Why does 1 equal 4? Vertical angles are congruent. Okay? 4 equals 8. Give me a reason.
Because vertical angles.
Think before you talk. Say it, Rachel.
Corresponding.
Corresponding angles. That's right. Okay? So watch. 1 equals 4. 4 equals 8. So therefore, by substitution or by a thing called transitive property that was in chapter 2, we'll talk about that a little bit later. So 1 equals 8. And what is 1 and 8? Say it. Alternate exterior angles. Okay? So let's jot this down. Alternate exterior angles are what? Are congruent. Let's list them. That would be angle 1 and what? Angle 8. Alternate exterior. 1 and 4 are not. 4 is interior. 1 and 8 are exterior. And what's my other one? Angle 2 and 7. All right, so those are alternate exterior angles. I know. All right, let's finish this up in the next video.